Good evening, sir.
Good evening.
Good evening,
Good evening, sir.
Good evening, one and all. Okay, so let's get started. Let's continue with our chapter on mathematics for quantum mechanics, MFQM. Yesterday, we just defined linear vector space, then we learned linear operator, then we learned Hilbert space, and we learned scalar product of two vectors in a Hilbert space. Because the thing was, we learned that Hilbert space is nothing but a linear vector space, but it should also have a defined scalar product. In order to understand scalar product, we did a lot of work. We learned the properties of different scalar products here and there. Okay, so now let's continue with this. After that, I think we also defined linear dependence, linear independence, and we learned basis of vectors. That is very close. So basis of a vector space was nothing but the number of linearly independent vectors in that space. Basis of the vectors. You have probably mentioned basis, or like you have written something like 5 1, 5 2, 5n forms the basis, if they are linearly independent. Okay, that is where we had stopped. Okay. So when you say linearly independent, it means they cannot have a relationship between them. I mean, if at all you plan to add them all together and say that like a1 5 1 a2 5 2 a3 5 3 an 5 is equals to 0, that will be impossible. All the constants will automatically become 0. They just cannot have a relationship between them. Okay. So after that, I want us to define today first topic, dimension of a vector space. Dimension of a vector space. It is similar to rank of a matrix basically. So it's like it is basically number of basis vectors. Number of basis vectors you have, or you can say number of linearly independent vectors you have. Number of linearly independent vectors you have. Okay. So suppose you have been given a relationship c1x plus c2y plus c3z is let's say 0. You have been given this for an example. And you are also given relationships between the constants. Suppose they have given you that c1 plus c2 is 0. Suppose they have given you that c1 minus c2 is 0. Suppose they have given you c1 minus c3 is 0. Something like this. I'm just thinking, creating different equations. Okay. So if something like this is given to you, and eventually you find out like 3 equations will be given between c1, c2, c3, whatever. 3 equations will be given. c1 plus c2 plus c3 is something. That way another equation will be given. That way another equation will be given. And using those equations, you will have to find the values of c1, c2, c3. Suppose you find out that c3 is 0. Suppose we find c3 is 0. What happens in the equation then? If c3 is 0, then here what happens is we end up getting c1x plus c2y is 0. Z becomes linearly independent. Simply. Okay, and x and y are linearly dependent of each other. So how many basis vectors do I have? Only one. One of them has become linearly independent. Now you can say that Z has become linearly independent. So the dimension of this vector space, or number of basis vectors in this vector space, or number of linearly independent vectors in this vector space, it is 1 basically. Make a note. Dimension is 1. I hope you understood what I'm trying to explain here.
So can you please go through the example?
So basically, they have given you this relationship between x, y, and z. This is given, and relationship between the constants is also given. C1 plus C2 plus C3. Suppose then you will have 2 C1 minus 3 C2 plus 4 C3 is something. That way, 3 relationship between the constants will be given to you, and you have to find a C1, C2, C3. So suppose we find a C1 some value, we find a C2 has got some value, but C3 is 0. But C3 comes out to be 0. In that case, what happens to the equation? In equation, since C3 is 0, you are left with C1x and C2y. So these two are dependent on each other, but C3 has become independent, and hence you say dimension is 1. There is only one vector who has become independent. So number of independent vectors are nothing but the dimension of the vector space. Clear?
Yes.
Okay. Make a note. Ask me if you have any questions again. No problem. If I had enough time, I would have tried to create a proper problem on this. But I think you understood the gist of it. Any questions, anyone? So dimension is nothing but the number of basis vectors, or you can say number of linearly independent vectors. So next, proceeding ahead. Let me know if you're writing. Okay, next. Give heading square integrable function. Square integrable function. Okay. So that is nothing but basically when the scalar product of two vectors in a linear vector space is defined. If that happens, then you can say that the function is square integrable. That's it. What did I say? A square integrable function is basically when the scalar product of two vectors is defined. Okay, it is finite. Yes. So basically, when you calculate psi-phi, how do you calculate psi-phi if you remember? Integration. The first one is the conjugate. The second one you have to write as it is. You must have a defined value of this. You must have a finite value of this. If that happens, you call the function to be square integrable. That's it. Make a note.
The square products of two linear vectors must be defined and finite.
Yes.
Right?
Yes.
In Hilbert space.
In
Or
Hilbert
any
space.
space.
No, in Hilbert space. Okay. In Hilbert space. Everything that we are learning in quantum, it is always going to be in Hilbert space. It means Hilbert space is nothing but linear vector space. Additionally, you say scalar product is defined. Scalar product is nothing but square integrable function. You are just giving it a different name. This is nothing but scalar product now. That's nothing but square integrable function. Scalar product. You have just given different names. Like if I tell you have learned beta function, what is a beta function? You write 0 to 1, x raised to n, and 1 minus x raised to 1 minus n, or whatever. So and then it's product of two things. You just give them a name. This is known as a beta function property, right? I'm not sure if you have beta, like if you have learned beta also.
Yes, sir.
So how does this is beta? Do you know the formula of this, by the way?
Yes, sir. Beta lambda.
Yes, sir, beta.
Yes. So like if you are going to write it like this, if this is x raised to n, and then you write it probably x raised to l, and what do you write here? M minus 1 or no, 1 minus?
Sir, x raised to l minus 1 होगा.
X raised to l minus 1 here, 1 minus x raised to n minus 1. Then you have gamma m upon gamma l plus m. That's it, right? So this is known as a beta function, right? Okay. So basically you write this as n and you write this as some another variable. N can be written as l minus 1, and let's say p can be written as m minus 1. Okay. Limits are important, 0 to 1 basically here. So you just call them. So here this scalar product, this value, it is known as a square integrable function as far as it's finite. So next, proceeding ahead. Let me know if you're writing, okay? Any questions, anyone? Next is Max Born interpretation. I've already told you people I'm following Zetli for our exam syllabus. It's a good book. Okay. So this is mod square, mod psi square dx. What is the meaning of this? Here is that mod psi square dx. It represents probability of existence of a particle between x and x plus dx. You can say probability of existence or position of a particle if you want. You can say probability of existence of position of a particle between x and x plus dx. Suppose if you write dE, then that would be represents probability of existence of energy of particle between e to e plus d. If you write dP, then probability of existence of momentum of a particle between e to e plus d. Understood? So basically, whenever you write mod of psi square dx, it's probability of existence of respective thing of a particle between the respective things. So you can write mod of psi square dE. That would be probability of existence of energy of a particle, okay, between e to e plus dE. E to e plus dE. Here also x to x plus dx. Okay. Make a note.
Psi is what? What is psi?
Wave function.
Wave function that we have
that is
associated with
the particle. Yes, wave function associated with the particle. Actually, we will be learning wave function in great detail later in when I will start with this chapter, postulates of quantum mechanics. Wave function associated with particle. As of now for you, psi is basically any vector in a vector space, in the Hilbert space. But later we will learn those vectors are wave functions. Psi 1, psi 2, psi 3, psi, all of them are wave functions. As of now, they are just simple vectors in Hilbert space. Okay. They can be complex. Remember, people, mod psi square is actually psi star, psi, don't forget. Or you can also write psi star, anything. They can be complex too. I've tried to give you enough amount of theory and data so that you will never require to read any other book if you're learning quantum physics. And provided you have attended, right, that's fine. But provided you have also attended the class, because many times only if you're reading through this, it becomes so yes. Shall we done? Next. Like right now I have written x to x plus dx. Suppose an exam they ask you find the probability of the particle that it exists between. They give you a reason. Let's say in a box they tell you that find the probability of the particle that it exists between 0.4L to 0.6L. What you will do basically integrate now 0.4L to 0.6L. Simple. Okay. So basically you can say probability of a particle can be in general written as a to b, which is mod of psi square dx. What does this tell us? This tells us about probability of the existence of the particle. Probability of the existence of the particle between also existence of the position of the particle. Existence of the position of the particle between a and b. You gave it limits this time. A and b. Yeah. And people, it's obvious if suppose you give a confinement to the particle. Suppose you don't know that where the particle will be in the box, but you at least know it will be at least somewhere in the box, like from 0 to L. So if you consider all space of the box, people, all space, yeah, what is the probability that the particle will be somewhere in the all space? Somewhere.
One.
Absolutely. It will be somewhere at least. But why do you consider the all space region? Okay. So we can also write that. I hope you copied this, or I'll just write it here. So the value of a to b, not a to b, like if you calculate mod psi square dx over all space, whatever space is given to you, okay, it is 1 people. So usually you can take all space from minus infinity to infinity, but then if they have given you confinement, like a box, you can write 0 to L or 0 to 2L, whatever box they have given. Okay. So all space is the space within which the particle can exist, at least exist somewhere. That way answer will be 1. Okay. This is also known as by the way normalization condition.
Yes, a normalization.
Yes, this is also known as normalization condition. What is the meaning of this? We'll understand soon. Like how does this help us? I think I can take a good problem right now only. Alternatively, in JAM, they have asked a question just on normalization condition, where they're asking you to find something else. So I'll just find a good problem on this right now. It will be best. But forget the good problem. Let's do one thing. Those who have learned 1D box, you know the value of wave function, right? It is root of 2 by L sine n pi by L. So we can do one thing. I'll not give you this. We will find root of 2 by L. Sure. Let's create a good problem right now. Sure. Suppose they have given you an exam that wave function of a 1D box, is psi equals to a sine of pi x by L. They have given basically the first wave function psi 1. N is absent here. Okay, so that's fine. Or you can write n. It will not affect our answer. Let's keep n. N is an integer. Okay. And n could be 1, 2, 3, anything. Okay. Okay. And they're asking you 1D box of length L, or 1D box of length L is this. Find a. That's it. Find a. So those who have learned, you must know a is actually root of 2 by L. We will try to find this. So in exam, basically what they will give you, they will give you a wave function. Sine is a e raised to something, or sine is a into x square minus 2, or anything like that. A into some function will be given, and they will ask you to find the value of a. That's it. So how can we find it using normalization condition? So what is the normalization condition? Integration of mod psi square dx. This is 1 over all space. This is how we can always find it out using normalization condition. A is also known as normalization constant by the way. So whatever constant you have outside the function, a f of x. So whenever you write sine is a f of x. So whatever constant you have outside, that is known as normalization constant. Write this above margin. If size a f of x is normalization constant. If size a f of x, a is normalization constant. Let's call this normalization condition. Okay. So let's try to solve this. Okay. Integration of mod psi square means psi star psi dx. All space length is L people, 0 to L. That's it. Okay. Dx. This is nothing but 1. In all space also they have given confinement. They have given that the box is of length L. That's it. So particle cannot go beyond the box. That is at least. So 0 to L. Substitute. Luckily, this is not a complex function. It's a real function. So the conjugate of this remains as it is. Conjugate of a sin n pi by L, that will remain a sin n pi by L. Okay. Conjugate of this also remains a sin n pi by L dx. This is 1. So a into a is constant. You can go outside a square.
So it can be a complex number, no?
A can be anything by the way. So sin square into n pi x by L. This is 1.
So it conjugate लेना पड़ेगा ना, एक का?
अच्छा, that way, like if you want to, like if you want to connect a star a, so technically it becomes mod a the whole square. So okay, they should give us that a is real. Okay, where a is real. I will write where a is real. At this, but good. Where a is real. I say it doesn't matter, like even if they don't give a is real. Actually, this only increases our step. Like you can keep this a star if you want, because a can be complex. So yes, so a star into a. So that way it becomes mod a square. And we have to see if this becomes real, then it will remain real. So that's fine. But okay, next. So let's solve this. Okay, let's say this is a very popular integration answer. This is L by 2. You can write this directly. Like when you have 0 to t, you write t by 2. You have 0 to 1, it's half. Integration of sin square theta, it's always half.
Yes, sir.
But we can solve this, no problem. So this is 0 to L of. So this integration of, when you write 0 to L of sin square n pi x by L. You can use this formula. Let's say half angle formula, people. What is half angle formula? This one. 1 minus cos 2 theta is 2 sin square theta. So I can say 1 minus cos 2 theta by 2 is sin square theta. Okay. So this becomes basically mod a square integration of 0 to L sin square theta. Sin square theta is 1 minus cos 2 theta by 2. So this is 1 minus cos 2 n pi x. 2 n pi x by 2. Sorry, by L. By 2. This is 1 dx. This is 1. I repeat, sin square theta is 1 minus cos 2 theta by 2. Sin square n pi x by L is 1 minus cos 2 n pi x by L by 2. I just applied the formula. Copy, please. Ask me if you have any questions. Okay. Next. So what do we have? Mod a square 0 to L. You can split the integration. So you have half dx minus integration of half into cos of 2 n pi x by L dx. This is 1. So you have mod a square into half you can throw outside. Integration of dx is x 0 to L. Half I can throw outside. Integration of cos theta is sin theta. So integration of cos is sin of 2 n pi x by L. But then you have to divide by the constant. So integration of cos theta is sin theta. Integration of cos 2 theta is sin 2 theta by 2. Integration of cos 10 theta is sin 10 theta by 10. So integration of cos this theta is cos this theta by this. So whatever is this, you have to divide. This 2 n pi by L. Okay. This is 1. So we have got limits also by the upper and lower limits. Upper and lower limits. Let me use a color here maybe. So lower limit is 0, upper limit is 0. Copy please. Okay. So mod a square into half into upper minus lower. So that's L minus 0 minus 2 to no sorry half 2 n pi and L goes in the numerator. So L upon 4 n pi. L upon 4 n pi into upper minus lower. So sin 2 n pi L by L minus sin 0. Sin 2 n pi L by L minus sin 0 upper minus lower. Okay. This is 1. So we have mod a square into L by 2 minus L upon 4 n pi into people L gets cancelled. Sin of even multiple of pi. Even or odd, sign of any multiple of pi is 0. Even or odd, sin 1 pi, 2 pi, 3 pi, 4 pi, even pi or odd pi. As far as it's even or odd pi, integral multiple of pi, it's anyway always 0. So the first one is 0, sin 0 is also 0. This is 1. Like I told you people, it's a very popular integration. Answer is L by 2. Okay, this is 1. Integration of sin square theta from 0 to pi by 2, it's half. Integration of sin square omega t from 0 to capital T, it's p by 2. Similarly here also the answer is L by 2. For one oscillation, basically. Whenever you have one oscillation, integration of sin square is basically half of the highest value. Okay. So this is mod a square into L by 2. The answer is mod a square is 2L. Mod a square is 2L. So we have got real value. Luckily, anyway, even if I would not have given the a is real, we got real value. So a is under root of 2 by L as expected. So these kind of questions are popular in exam where they ask you to find a normalization constant. Clear? Nice. This was unplanned, but nice. Any questions, anyone? But it's not necessary they will always ask you to find normalization constant. They can also ask you find the probability that the particle exists between this and this, like 0.4 and 0.6. Let's do that now. Let's do that also. I hope you have copied this. Tell me if you're writing these. Actually, I want to ask before because we are discussing this. So sin of n pi is always 0, like you know. Understood this, right? 1 pi, 2 pi, 3 pi, 4 pi, even pi, odd pi doesn't matter. Integral multiple of pi is 0. What is cos of n pi?
Minus 1 to the lower end.
Minus 1 to the power n.
Good. So you know this. Then fine. Cos of n pi is minus 1 this way. So basically, if n is even, you get 1. If n is odd, you get minus 1. So cos 0, cos 2 pi, cos 4 pi, cos 6 pi, it's 1. But cos 3 pi, 5 pi, 7 pi, 9 pi, that's minus 1. Chalo, next. So same question. Now that you have found out normalization constant, they won't give you normalization constant directly. They will give you only this only. Suppose they have given you that psi of x is a sin n pi x by L. They have given you only this, suppose. And they have mentioned that x is between L and 0, basically 1D box. Okay. And they're asking you find probability that particle exists between 0.4L and 0.6L. Something like this. Okay. So it's basically we just learned now probability that particle exists between A to B. So that's what A to B. You have got 0.4L to 0.6L. And then mod psi square dx. But the problem here, what would have been is when you calculate this, A is unknown. So this is a two-step process. First, you use normalization condition to find the value of A. After finding that, what you do is you substitute or you calculate this. So it's a two-step process now. So first step already done. We found out the value of A. Because we got A, we got psi of x. So what do we get, people? So because we want to find this, we first found out A, people. We found A. Okay, because a you will require a, right? How can you solve otherwise? So we found a, and after that we got that psi of x was root of 2 pi l sin n pi x pi, and now we can solve further, and now we can substitute this here. Copy.
सर
बोलो।
ए का वैल्यू रूट 2 बाई एल आया ना, फिर साइन एन पाई बाई एल क्यों लिखा?
अरे मैंने a थोड़ी लिखा है, psi लिखा है।
नहीं हाँ साइन, अच्छा ठीक है ठीक है।
a is only root of 2 pi l. I've written psi x is a sin n pi x pi. Then people.
Yes.
So, let's substitute. So probability. What do we have? Integration of 0.4l to 0.6 l mod psi square. So let's square this. Again, it's real and directly square. Doesn't matter. So root 2 by l that becomes 2 by l. Sin n pi x that becomes sin square n pi x pi dx. So now I can put 2 by l outside. We have got 0.4l to 0.6l of sin square n pi x pi. Now don't write l by 2 because it's not 0 to it. Now you have to solve. Do not write l by 2. So we already have solved the integration at least. The integration value of this was l by 2 minus l upon 4 n pi into, I don't remember after this. L by 2 l upon 4 n pi sin 2 n pi. Sin 2 n pi x pi. Sin 2 n pi x by 2. See, x by 2, not l by 2, sorry, I wrote it wrong. X by 2, this value are going to get x by 2, and then l upon 4 n pi sin 2 n pi x by l. Okay, we can go. So we are going to get here, after you integrate this, x by 2 minus l upon 4 n pi sin 2 n pi x by l. Tell me if you have any questions. Lower limit is 0.4 and upper limit is 0.6 l. We are yet to substitute the limits. Integration is same, right? Integration is not changed people. So I can directly write this now using previous steps. In exam, obviously you have to solve. I have used the previous step. Copy this much. And tell me if you have any questions. Don't hesitate.
So last page once.
Sure.
Okay. Thank you.
Let's substitute and calculate. So what do we have? 2 by l into upper minus lower 0.6 l minus 0.4 l. That's 0.2 l upon 2. 0.2 l upon 2 minus l upon 4 n pi. L upon 4 n pi into upper minus lower. So sine of 2 n pi x into 0.6. Sine of 2 n pi x is what people? X is 0.6 l. L gets cancelled out. So you just have 0.6. 2 n pi 0.6. 2 n pi 0.6 minus sine of when you write substitute 0.4 l, l gets cancelled. 0.4 into 2 is 0.8. Okay, or you can just write 2 n pi 0.4. L gets cancelled. Copy this. Take your time. Ask me if you have any questions. sorry. So why do I feel that they should give us n this time? They have to give us for which state are we calculating? Ground state, first excited state, second excited state. Otherwise, depending upon the value of n, answers could be different now. Okay. So 1.2 n pi. 1.2 pi we can find, but the value of 1.2 pi and 2.4 pi would be different. So just use calculator somebody and tell me the value. Suppose if you write sine 1.2 pi and minus sine 0.8 pi. Calculate this and also calculate. So I have basically substituted ns1 right now. Let's substitute ns2 and what happens? So in that case, 2 to the 4 and 4 into 0.6, that's 2.4 pi minus sine of, here also if I substitute 2 to the 4, 4 minus 0. Okay, so this is 1.6 pi. Calculate, see, are they same? If they are same, then it's fine. If they are not, then exam, obviously, they have to give us for which level are you calculating probability. Calculate these two values. Check, please. Ensure that your answer is in radians, not degrees. I will also check it. Sine. First, let me check if my value is in sine by 0. So if I write sine pi by 4, I'm getting perfect. Okay. So this is giving me values in radians. Sine 1.2 pi. I got a value. Minus sine 0.8 pi. I'm getting minus 1.175. Okay. And if I use n equals to 2, then sine 2.4 pi minus sine 1.6 pi. No, I'm getting a different value, 1.932. Okay, so they have to give us an exam for which level. So add for this question, people, add for this question that here in the question, find probability that the particle exists between 0.4 L and 0.6 L in ground state. In ground state, n equals to 1. Add this, please. Earlier it was not important. Earlier it was always becoming 0. Now it's important. In ground state. Okay, I'm just creating these questions. Obviously, I will know as we solve that what are the missing data I should have in the questions. Okay, done. So
yes.
if you substitute n equals 1 and I'm getting this value, you can also confirm with this with if I'm getting this or not, like if this is correct or not. So this is 2 by L, 0.2 upon 2, that's 0.1 L, okay, minus n you have to n is 1 by the way, n is 1. So L upon 4 pi, n is 1 into minus 1.175. Okay.
एक्सक्यूज मी सर
बोलो
सर अगर हम साइन a माइनस साइन b का फॉर्मूला लगाएं तो हमारे पास आता है साइन 2 साइन a प्लस b बाय 2 एंड कोस a माइनस b बाय 2 तो 0.8 और 1.2 को प्लस करेंगे 2 आएगा 2 पाई बनेगा तो 2 पाई को 2 से डिवाइड करेंगे साइन पाई हो जाएगा तो साइन पाई 0 होता है वहां से भी तो देख सकते हैं
मैं समझा नहीं बट ओके आई विल ट्राई टू फॉलो द स्टेप्स यू सेड वेट टेल मी फ्रॉम बिगिनिंग फ्रॉम वेयर आर यू ट्राइंग टू कैलकुलेट
सर वी कैन अप्लाई द फॉर्मूला साइन a प्लस साइन b
फ्रॉम हियर
यस सर फॉर n इज इक्वल टू 1
नहीं
Sin A.
ओके वेट ओके फॉर इक्वल्स 1 यू आर गेटिंग साइन ऑफ 1.2 there 1.2
नो नो सर इफ वी हैव एन आइडेंटिटी साइन a माइनस साइन b इज इक्वल टू
that's okay wait sin a minus sin b okay so that's sin of 1.2 pi into sin of 0.8 pi that
यस सर
okay
yes,
right Okay, so you are using the formula sin c minus sin d. So that's
Yes, sir. From there on we can calculate.
but what is the value there? If you use sin c minus sin d, I don't know. Sin c plus sin d, sin c minus sin d, you have sin cos, sin, cos, sin,
Two
cos,
cos,
sin. 2
cos
cos sin, 2 cos and sin. So 2 cos of 1.2 pi, 0.85, and then 2 sin
into
of
cos
1.
cos ही आएगा सर.
Cos cos आएगा?
Yes sir, sin में pure cos ही आता है.
Okay, okay. 2 sin c plus sin d, sin c minus sin d, sin cos c plus cos d.
Sir
Cos c
sin
minus
आएगा
cos
sin.
d. है ना?
I forgot it.
हाँ. Because I have remembered a trick with the help of which I remember this. Like I remember sin c plus
Yes sir,
sin
sin
d,
में mix आता है.
then sin c minus sin d, and then cos c plus cos d, and then cos c minus cos d. I remember it in this order always. And
A
I
minus
remember
B over
this
sir.
is 2, 2, 2, 2, and then here you have sin cos cos sin. That's how I remember. And then you have cos sin cos sin. So let's take some time to understand. So you have cos sin, but first is a plus b by 2, other is a minus b by 2. So you have 0.4 pi by 2. But huh, it doesn't mean you get the value, and then you get the same answer. Check. If you're getting same or not, I have no problem. And then you will get the same result. Check. So you're getting 2 cos of 2 pi by 2, sin of 0.2 pi. So you're getting 2 cos pi sin 0.2 pi. Cos pi is minus 1. So you're getting minus 2 sin 0.2 pi. Check. We are getting minus 2 into minus 2 in wait. Minus 2 into sin 0.2 pi, no? Sin 0.2 pi. I'm getting minus 1.175. Same answer. Either way, it's up to you. However you want to do it. You'll get the same result. But this is also absolutely
Yes,
fine.
sir.
But I personally don't enjoy this because you have access to calculator directly. No? Like here you can directly use calculator. Why do you want to solve and then use calculator? Exactly, you're using calculator. So use calculator and you have access to calculator. You can, but okay. Anyway, so proceeding there. People
All
do,
these calculations are in radians.
absolutely, absolutely, absolutely. No radians, inside it must be radians. Huh? Yes. Okay.
Okay, sir.
So, and people in between also, like when I talk about beta function or like trigonometric formulae, if you don't understand those things, you can tell me. Let's could you please give us an idea about these formulae? I don't mind sharing those again. Okay. So this is how I remember, like I said, sin c plus sin d, sin c minus sin d, cos c plus cos d, cos c minus cos d. This is basically like a music, no? Sin, 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 cos, 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 minus cos. And then I remember sin, cos, cos, sin, cos, sin, cos, sin. Till date, since 12 years, I take 10 seconds to memorize this music, and then I identify that the formula is this. Okay. But okay. Anyway, so final answer. LL gets cancelled. You can take L common. LL gets cancelled. So answer is 2 into 0.1 plus 1.175 upon 4 pi, which is 2 into. Wait, first 1 plus 1 divided by 4 pi into 2. No, it's not 1, it's 0.1. It's 1.175 divided by 4 and then divided by 5 and then plus 0.1 and then into 2. Perfect. This should be a close answer. 0.38. 0.38. Please tell me from LSA 0.37. So technically it's 0.39 if you use approximation rule. 0.39. Any questions, anyone, anywhere, please ask. Don't hesitate. Did you understand? Calculation is fine. You have to use calculator. At the end, the process I hope is very simple and very calculated. Okay. Chalo, proceeding ahead. Now, what I wanted to teach, let me first find that. So we diverged a lot, but very important divergence. Related to these questions are always there in the papers. So we learned normalizing condition. And so basically, if you remember yesterday, we had learned that this value, mod of psi squared dx, we had learned it is always greater than or equal to 0. And I made you write it's real and positive. Now we also know it is also less than or equal to 1 because it tells us probability now. It's also less than or equal to 1 because it tells us probability. So real and positive, and it tells us probability. So answer, the probability that the particle will exist is 0.38, which is a good amount of probability. And it should be, I tell you one thing. If I give you a good region from 0 to L, okay. So if I'm telling from 0.4L to 0.6L, which is a good amount of region, so probability of existence of particles should also be good, and it is good. But we found out the value is found as 0.39, which is good probability percentage. 39% people, it's good percentage. Okay. Chalo, nice. And for a second, if some of you are by any chance thinking, sir, but in a small region of 0.4L to 0.6L, we are getting 39%. The difference is only 2. It means in remaining we are getting only 61. This is consuming only 0.2L area, no? 0.4 to 0.6. This is consuming only 20% length. So in this 20% length, we are getting around 40% probability. So sir, in the remaining 80% of the length, are you getting only 60% probability? Yes, people, because actually this is first mode. And if you remember the idea of Rayleigh, who compared this with stationary waves, which is going to be correct by that idea, it will form a loop. And where do you think maximum probability rises? 0.4 to 0.6. As you go away from the center, probability decreases. In the center region, probability is maximum. Okay. Anyway, next. Proceeding ahead. Give me a minute. So that was all about these LBS and Hilbert space we wanted to learn. Now please give heading Dirac notation because we started at this. Please give heading Dirac notation. Okay. First of all, people in classical mechanics, what determines the physical state of a system? Usually there are two coordinates. One is momentum, other is position. In classical mechanics, to understand the state of a system, like they ask you to find the state of the system. It means you want to find position of the system, you want to find momentum. If you have information of position and momentum in classical mechanics, you can find anything else. You can find kinetic energy, you can find work, you can find power, you can find impulse, force, whatever you want. Everything else can be followed once you have information of the position of the particle and speed of the particle at that particular instant. When you say momentum, it also includes mass and speed both. So mass, speed, and position. Technically 3 coordinates, but you convert it into 2 by saying momentum and position. 2 coordinates, 2 variables are required to understand everything in classical. In classical mechanics, in quantum mechanics, we require only one such coordinate. Literally, only one coordinate, and everything else you can find. And that is the wave function. Once you have the information of the wave function, using that, you can find anything and everything in quantum mechanics. You can predict the position of the particle, which we just did by the way. We found out the probability of the position of the particle using wave function. You can find energy, you can find momentum, you can find whatever you want in quantum just with the help of a single variable, and that is wave function. Okay. So wave functions are nothing but elements of vector space. But remember, wave functions corresponding to different energy levels are different. Like I made you write the formula. Psi is root of 2 pi L sine of n pi x by. So wave function depends on n. So this is actually psi n, you can see. For ground state n is 1. For first excited n is 2. For second excited n is 3. So wave function changes as the energy changes. But at the end, wave function can be converged into one single formula. Okay. So the point is psi 1, psi 2, psi 3, psi n. These are now henceforth going to be the elements of the vector space. Psi 1, psi 2, psi n are going to be our elements of vector space. And we don't want any other variable in the vector space. We don't want any other variable in this vector space. They are sufficient to find everything. Okay. Next, they represent physical state of a system in quantum mechanics. They represent physical state of a system in quantum mechanics. Because if you have information of psi, you can literally find everything about the state of the wave. You can find energy state, you can find position, you can find momentum, everything. They represent physical state of a system in quantum mechanics. Okay. Next, we denote state using a ket vector. So for example, you can, the ket vector is known as something like this: one single slash and then kind of a greater than or equal to sign. The triangular, the closing triangular brackets. These are curved, like these are what you call it. Curved brackets? No, these are curved brackets only. Square brackets, curved brackets. So these are also curved brackets. What do we call this? This is square bracket.
First bracket, second bracket, third bracket.
Hey. So that's like Peter 1, Peter 2, Peter 3. Okay, leave it. So square bracket, we have this and we have also this. But if this is curved, then this is not curved. This is
Parenthesis.
parenthesis is fine. That is an English term. But
The simple bracket.
simple bracket. Sure. Okay, anyway. So anyway, we denote state using a ket vector. So this is a slash, straight slash, and this is closing triangular bracket. This is known as open triangle. This is known as closed triangle. Closing triangle bracket. So for example, you represent them like this. Psi. This is state of a vector. State of wave function. Okay. Sorry, state of just cited wave function. Wave function. Okay. This is how we denote them. You can call them state vectors. That's fine. Ket vectors. Ket vector, state vector, anything. Okay. Next. Remember, wave functions can be complex. I already told you that. Okay. Psi star psi. So the conjugate of these ket vectors are represented by bra vectors. Okay. So these are open triangle. You have open triangle and then slash. These are known as bra vectors, and you can keep psi here like this. So this is conjugate. This is equivalent to psi star. Okay, and this is equivalent to simple psi. This is simple psi. This is equivalent to psi star. Conjugate. Okay.
So, sir, if we include psi in that ket vector, yeah, it becomes a wave function.
Yes. No, I mean, henceforth you will denote them by this. But even if you don't denote it by like this, is still a wave function. It's not necessary they will write it like this. They can also use this notation. But this is a standard notation. Now there are follows throughout. Okay.
This is a standard notation for wave functions in quantum mechanics.
Yes. Henceforth we are only going to use this. They have to write always that wave function is this. It is given by, let's say, they will give you a1, psi1, a2, psi2, whatever. But whatever wave functions they will write, they have to write it in the bracket notation. Now these are the standard notations. But before there came with these notations, we used to use simple psi, we used to use simple brackets, and we had made a rule that left one is conjugate, right one is simple, everything. But he came up with these different notations. Chalo, next. Proceed ahead. So basically, when you write psi, it is equivalent to scalar product. This is a scalar product, people. So how do you find scalar product? Integration of psi star, psi dx. I hope you realize it's one and the same thing. The left one is actually psi star, as expected, because this is bra vector. Bra vector is what? Conjugate. And the ket vector, this is ket vector. Now, ket vector is simple one. Ket vector is simple one. So if you write phi psi, okay. So you have first written bra vector, then you have written ket vector. So the bra vector is the conjugate one, okay, and the ket vector is the simple one. Simple. So this avoids the confusion henceforth. So whenever you want to write conjugate, we'll always write bra vector. If I've written this, it means it's conjugate. If I've written this, it means it's simple.
Sir, what is meant by state of a wave function or state of a particle?
Something which tells us, like, gives us information about the condition of it, like in what state you are. So I'm on chair, I'm right now in good mental health state, my mass is this much, I'm at rest, whatever information you can get about your existence. So if you want to say a state of this mobile phone right now, so I can tell you that it is at rest, basically momentum is 0, and I can tell you the position, I can give the latitude of the earth right now for this thing. So that gives the state of this. In quantum mechanics, wave function is sufficient to understand a state, because once you have wave function, you can find everything else in quantum. Clear? Okay. No problem. Proceeding ahead. Okay. So properties of bracket vectors. It's very similar to what we have already learned yesterday. Sorry, properties of bracket. So first, to every ket vector, there exists a bra vector. So basically, to every wave function, there will always be a conjugate. Okay. So you can say, or you can also write that if you have a ket vector, you can take conjugate of this, and what you will get immediately, this will convert itself into a bra vector. As simple as it. So this is nothing but conjugate of psi. Okay. This is conjugate of your ket vector. Simple. Second. Then after deciding the properties are well known to us, if I give you a into psi the whole star, what happens, people? A, remember, it can also be complex. A star, but this ket vector will become bra vector immediately. Okay, that's also fine. अच्छा वैसे just technically speaking, in जैसे in matrices we have learned the rule that A into B transpose. It's not actually A transpose B transpose. We are technically supposed to write it as B transpose A transpose. You have to shuffle the order also by taking the transpose. Same goes for I think Hermitian matrices as well. If you take dagger, like conjugate of the transpose, then also you have to write D dagger either. You have to shuffle the order. So here also maybe we can use the same logic. I'm not sure how much it will affect the idea, but let's keep it. Now it doesn't. I mean, this is more correct than writing it the other way around. Okay, so I'm just shuffling the orders. Have you understood what I meant here? I'm using the idea of matrices that AB dagger is not A dagger B dagger. It is always B dagger. You have to shuffle the orders. AB transpose also it is B transpose A transpose. Dagger is conjugate of transpose or transpose of conjugate whatever. Pardon?
But sir, I think conjugate में order shuffle नहीं होता.
नहीं अगर होता है तो फर्क नहीं पड़ता है ऐसा बोल सकते हो.
Yes, sir. Yes.
हाँ conjugate में that's what I mean. Right now I'm using conjugate. Eventually when we will have Hermitian matrices, when we learn Hermitian operators and quantum mechanics, these rules will become important. So why not apply them right now? Here even if you do shuffle order, I know that it's not going to be very important. But if you make a practice of this, chances of committing error ever will be reduced. Here it doesn't affect. So it doesn't matter if you put it like this or not.
Yes, sir.
So we'll
बट
put it
सर
like this.
जब पहले ए स्टार लिखा था फर्स्ट में और उसके बाद ही ब्रैकेट लिखा था और जब आपने सफल कर दिया तो ए स्टार राइट साइड जाने के बाद डैगर हो जाएगा ना तो फिर तो चेंज हो जाएगा
नहीं समझा नहीं मैं एक मिनट. Pardon? Which one? This one or this one? Which are you speaking about? This one or this one?
या फर्स्ट वन
हाँ, first one. हाँ, so it's like basically you have to open the brackets. So this actually becomes A star and psi. But I'm just saying that we will shuffle the orders. Like instead of not psi, star applies to A, so A becomes A star. Star applies to your ket vector, it becomes bar vector. But just that instead of writing this here, I'm writing it on the right side. Here it doesn't matter to be honest. You write it on left, write it on right, both are correct. Just that later when we learn Hermitian matrices, order will become really important. Like Hermitian operators, it will become important. So I'm just trying to make you a habit of it. Here it doesn't matter how you write, but then when it matters, if you already have the habit of writing it this way, you'll not commit any mistake. That's it. So you write anyway, it is fine. I don't mind.
तो मैं एक्चुअली बोलना चाहती हूँ कि मतलब लेफ्ट साइड में जब होगा तो स्टार ही रहेगा पर राइट साइड में जब आप करेगा तो उसका डैगर हो जाएगा ना
Dagger क्यों होगा? It's conjugate only, no? It's conjugate only. It's not transpose. Why dagger? Dagger is conjugate only. It's not transpose at all. You're only taking conjugate. I'm not taking dagger of it. This was just to give you an idea of. Forget this. We're learning only conjugate right now. Okay. Next. Third. Proceeding ahead. So वैसे similarly people, phi psi, the whole star. That would mean what? Psi. Basically, when you're applying conjugate to both of them, bra will become ket and the ket will become bra. Khatam. So the one who was ket vector, that becomes a bra vector, and the one who was bra vector, that becomes a ket vector. This one we learned similar yesterday. We wrote it like this. Phi psi the whole star. We wrote psi phi now. It's one and the same thing. Just with a different notation. So you apply conjugate to, remember it's applying to the whole now. We don't show whole, but it means you're applying it to the whole. We don't show whole, but it's applying to the whole. Okay. Tell me if you have any questions. Don't hesitate. Next, proceeding ahead. Now, so I want to just say ask a question here for property that the value of phi psi becomes equal to psi phi becomes in which condition? Like when this happens? When happens? When there are multiple cases. The first and the simple case, obviously when pi and psi both are equal. Obviously, when both are equal. So in that case, phi psi will be psi phi. Right now only you learn phi psi the whole star is a psi phi actually. So I cannot say that phi psi and psi phi are equal. You can say phi psi and psi phi are equal only if you have I mean phi and psi both will be equal in that case. Only then it's fine. No? It doesn't matter how you're writing the order. If you're not understanding this, maybe what we can do is we can expand this. Like what is phi psi? It is integration of phi star psi dx. So I just said if phi and psi are same, I can write phi star as psi star, and I can write psi as phi because they are same, no? But what is psi star phi? Psi phi or bracket. So this is one case one. Copy, proof of it. There are multiple cases. So I just use phi star and psi is phi. Don't hesitate to ask me your questions. Throw your questions as if they are bullets. Keep asking.
Yes, sir.
Okay. Then tell me anybody's right now. Then there is another case, B case, which I would like to say when both are real, when phi and psi both are real. Why? Because what is the original formula, people? Original formula is I can write phi psi as psi phi the whole star. This is the original formula. But you are telling me find the condition when this is equal to what you are telling me. Find the condition when this is equal to psi phi. So if this is always valid, this is always valid. And if you want to find the special condition when this is valid, like you want to find the special condition when this is valid. So A is B, B is C, then A is B and A is C. So B is also equal to C. These two are also equal to each other. Okay. So if you equate them, what do you get? Psi phi star is psi phi. So when a vector is equal to its own conjugate, when it's real now, when it's real, simple. So if they are real, you will get the values. So this is always valid only when you can say they are real people. We learned this yesterday. If you remember, Z star was Z only when they are real. Only when they are real. Okay. Take a look. So another case is when both are real. Any questions?
Yes, sir.
Okay. Good. Then.
These two cases are compulsory, A and B, for this equation.
Either of them should be correct because this is not always correct. No? Always correct is the third one. Phi psi the whole star is psi phi. Phi psi the whole star is psi phi. This is always correct. But phi psi the whole star is psi phi. This is always correct. If you want to remove star, that's what was. If you want to remove star, then when it is possible. Either this is correct or this is correct. Either of them should be there for this to be correct. So this is not always correct. Understood? This happens only in either of these conditions. This is always correct. Always. Understood? Tell me if not. Yeah.
Yes, sir.
This I don't know if you want to write. So this is always valid. This is right now condition you are asking. You're asking this condition. So I just equated this. So basically, when you say Z star is equal to Z when Z is real. So that's important.
Yes, sir.
Okay. Actually, listen, technically, more technical. So it means Z is real. No? It means this whole term should be real. The value of psi phi. this value of psi phi that we have, that should be real. Wait, we have another condition. So that condition I should write first, but okay. So another condition is that the value of psi phi is real. Okay, interesting. Value of psi phi is real. It does not mean that psi and phi should necessarily be real. What if both are complex? That's also fine. Even then, the product can become real. No? Yesterday we calculated, if you remember, a plus bi. This is a complex number, and a minus bi. This is a complex number. But if you take the product of two complex numbers, you're still getting a real number. You get rid of complex. Okay. So psi phi is real, but it means psi and phi could be conjugate. Like they can be complex actually. So no, this is not a condition. Cancel B. B is not. I mean, B is a special case of this case. B is a special case of this case actually. I repeat. When is z equals to z star when z is real? So if this is equal to this star, it means this is real. This whole term is real. Product of psi and phi is real. Product of psi phi is real. So suppose this is your psi vector, okay, and suppose this is your phi vector. So if you calculate the product of them, you're getting a real value. Now. Does it mean that this is real? No, this is still complex. This is still complex, but their product is real. So this is not a compulsory condition. That's fine. It can be real, it can be imaginary. Cancel that. It can be real, it can be imaginary. If it is real, then this is correct. There is no harm by the way. I mean, that point was not incorrect. You can say both are real, you will get this value. But you cannot say both are only real. Both can be imaginary also. Only word is important. You can never say that both. This will be correct when both are only real. Even if both are imaginary, you are still getting the condition. Any questions? Anyone?
So what must be concluded?
So conclusion is that at the very end that these two are equal. One simple condition when psi and phi both are equal. Okay. Second is that psi phi is real. That's it. That's the product of psi and phi is real. It does not matter what is psi, what is phi. Psi individually could be complex, phi individually could be complex. Psi individually could be real, phi individually could be real. As you see, this is psi which is complex, phi is also complex, but their product is still real now. And if psi phi is real, then what does it mean? Psi phi will be equal to psi phi star. If psi phi and psi phi star are equal, then you can say you get this. Wait, I will write it this way. Not helping, but okay. So we just said that phi or psi phi, whatever, the value of psi phi is real. It does not matter psi and phi are complex or real. It could be anything. Psi individually, phi individually could be complex or real. We don't care. Could be complex or real. And I just proved that with this example. I think you understood this example. Psi is complex, phi is complex, but the product is real. Okay, good. So since psi phi is real, what does that mean? Psi phi is equal to its conjugate. Simple. Z is z star. Okay. But you just proved, you also just proved that equation 3, phi psi star is psi phi. You proved that phi psi star is psi phi. So you proved that phi psi star is psi phi. So phi psi star, what is psi phi? Psi phi star. Star star gets cancelled. You are left with phi psi is equal to psi phi. Proved it. That's what you wanted. Now, when does phi psi and psi phi becomes equal? Only when psi phi is real. The product of psi phi is real. Or you can say phi and psi both are equal. That's also fine. I hope this helps now. People, any questions? Anyone?
Just a minute, sir, copy.
Take your time. You can write if psi phi is real, then z is z star. That I'm using that if z is real. Okay. But this is always correct. But we know this is always correct. So that's it. A is B, B is C, therefore A is C. Therefore, we have already taken more than 60, 70 lectures, and by the time you should be aware of the fact that I will not mind if you will ask me to re-explain. Done? Copied? Should we proceed?
Yes, sir, we know that.
Okay. Chalo, next. Proceeding ahead. So that was done. Basically, it is just a good MSQ kind of stuff again they can create. This is valid when, and there could be 4 options. One is when this condition is met, one is when this is real. If they write that psi and phi are real, it's fine, people. It is correct. This is still correct. But if they mention psi and phi must be real, like something like this, that's wrong. No? It's not compulsory that they must be real. That's what I'm trying to tell you.
Yes, if they are real, then the product also real.
If they are real, then they are real. No problem. But if they are complex, then also they are real. That's what we checked here. That's what we checked. Then also they are real. So must be that English is really important. If they write that they must be real, then it's incorrect. It's not compulsory condition. Okay. It's like saying that cos theta is equal to 1. Is this correct statement or not? This is correct. But if they tell cos theta is always 1, obviously it's not always 1. No? It is also less than 1. Something like that. Okay. But next. Proceeding ahead. Then how many properties did we learn? 4, I think so. 5. Let's learn 5. So after this, we know psi of A side, like psi of A phi, whatever you're writing. If you throw A outside, can we conjugate or not? What will happen to A?
No conjugate.
No conjugate. Because you're trying it from the K vector from right side. So no conjugate. So yesterday's rule completely. Okay. So if I give you again A side and phi, now if you throw A outside,
A star.
Yes, sir,
A star. So yesterday's idea completely. And then whatever we learned yesterday, same rules of scalar product. Same rules. Cut, copy, paste. Okay. Cut, copy, edit, and paste. Somewhat edit. You have to replace the brackets with the bracket paste. Okay. So same rules, all the same rules. If you want, you can leave pages or just write cut, copy, thoda sa edit, and then paste. Chalo. Don't cut. Otherwise, it will be deleted from there. Just copy, edit, and paste. Proceeding ahead. Next. Okay. Number 6. So again, I was checking those NCTE papers, and one of those papers they had asked which of the following is a squarce inequality. Like that. Okay. So it's again related to quantum only. So if you have something like squarce inequality, they have given us, hang on, mod magnitude. This is magnitude of psi phi the whole square. This is always less than or equal to the value of psi psi, the value of psi psi, and phi phi. Product. Copy this. I will then try to explain that how did I try to understand. So right now, obviously, we don't understand what it means, but I can try to explain. Okay. People have already told you at the very beginning yesterday, the best way to understand quantum mechanics and scalar product is compare that with dot product in vector world. You know? So if you compare this with dot product vector world, I think you'll be able to understand. Psi and phi have a dot product between them, a bar dot b bar. Okay, you have to calculate the square of it. It should be less than or equal to. I can say this is a bar dot a bar. A bar dot a bar is a square now, and this is b bar dot b bar b square. Or you can say magnitude of a square. You can also write a bar dot a bar is magnitude of a bar square and magnitude of b bar square. Okay, so we can check this. Like if you want to understand, I hope you understood what I tried to do. I just related quantum with vector algebra that we are comfortable with. So this is scalar product of psi phi, a bar dot b bar, and then it has square. This is scalar product of psi with psi. So this is a bar with a bar dot a bar, you can write a bar the whole square. So phi with phi, b bar dot b bar or b square, magnitude of b square. A bar dot a bar. This is like a cap dot a cap. A into a is a square. A cap dot a cap. I dot I is 1, b dot is 1, a dot is 1, a cap dot a cap will be 1. You have a square. A is what? Magnitude of a vector now. A bar dot a bar is this. I hope now it's okay. So we can check this whether this is correct or not, and you will be satisfied with this positive equality. Take random examples. Create your own vector. Give any values to a vector and b vector and check. So suppose if I give, let's say a vector is 2 I cap minus 3 j cap. Suppose I give b vector is 4 I cap minus 6 k cap. I don't know, or j cap, whatever. Okay. Let's calculate a bar dot b bar. So what do we have? I dot I is 1, 8. J dot is 1, minus 3 into minus 6. That's plus 80. A bar dot b bar is 26. So we have what? A bar dot b bar the whole square. That's 26 square. I've never had it this way. What is that? 25, I know. 625. What is 26?
676.
676. Okay, good. So that's this. Proceeding ahead. Now, magnitude of a bar square. Okay, magnitude of a bar square. Magnitude of a bar square. So that's magnitude of this under root of 2 square plus 3 square, the whole square. Root gets cancelled. So you just have 2 square plus 3 square, which is 4 plus 9, which is 13. And magnitude of b bar square, which is under root of 4 square plus 6 square. That's magnitude of b bar. Okay. And then you have calculate square. Root 10 square gets cancelled. 4 square plus 6 square, 24 plus 36. This is 60. We're going right? How good? Do you think?
16. 24 again, sir.
Sir, 50.
Oh,
4 plus
16 in plus 36. This is 52.
Yes.
So calculate a bar square into b bar square. What do you have? 13 into 52. What is this value?
76.
Array. But we are getting equality, no? I mean, it's fine. Equality is correct. Now I'm thinking then LP will get less than. And why are we getting equality?
Sir, because of cos theta.
No. There is no cos theta times magnitude anymore. When will we get less than here? You copy this? We got equality, that's correct, that's good. But then when... Okay. I want you to check one thing right now. Just make this 5 and see are you getting less than 5 or 7 or anything. Instead of 6, try please try this right now. A very beautiful observation. Make this 5, 7, anything. Just change this value and see are you getting less than in that case. Change this one. Make it 5. So calculate again. Do this please and tell me LHS analysis both. Perfect. Outstanding. 5, 7, anything, and just check are you getting less than. You should get less than. I hope so. Do it patiently.
Yes, sir.
क्या क्या मतलब left में right में?
Yes, sir. A dot b whole square is 529. And a mod square into b mod square is 533.
Okay. See what I think. I don't know how logical this would be. Equality is possible only when a vector and b vector are linearly dependent. See, I don't know how logical it is because see, b vector is twice of a vector. Basically, they're parallel to each other. So I think that's where you are also saying that cos theta idea because b vector is parallel to b vector absolutely. Like this is just twice of a vector, simple. This is just double. 2 ka 4 and 3 ka 6. So if at all there is no linear combination relationship between them, you will get, I think so, less than 2. So I would like to claim here, but in your time pass period, you can try with random examples and see if this is always correct or not. As of now, I would like to claim here that equality exists when a vector and b vector are linearly dependent. But I will put a question mark, just like newspapers does, that this actor was removed from this movie and then question mark because they even don't know about it. Okay, so equality exists when a vector and b vector are linearly dependent. That's what I think, but then I don't know. Okay, when else could equality exist otherwise? Huh? Okay, but actually there is another equality, another inequality which we can learn. Number 7, triangular inequality. Hang on, we can check in that also if that's correct. Then this is an outstanding realization. Okay, triangular inequality, which is something like, where is it? I never had these equalities by the way. Mod of psi plus phi into psi plus phi. This is equal. This is less than or equal to under root of psi plus under root of phi. Okay.
So psi phi are matched.
Pardon? And I think there should be an under root here also.
I plus phi and
phi plus phi. I think psi plus psi and phi plus phi. That's psi, no? My handwriting. Okay. Psi and phi. Okay. So what in vector world, how does this look like, people? This is, by the way, mod is psi phi the whole square. No? What is people psi? It is mod psi square, correct? Mod psi square. So what is under root of psi? That's under root of mod psi square, correct? So that's just mod psi. Just mod psi. Magnitude of psi. So I think this is magnitude of a vector plus b vector. Don't you think? This is magnitude of a vector plus b vector. I repeat, how did I try to understand this now? So this is psi plus phi. What is the meaning of that? The meaning of this is under root of mod of psi plus phi the whole square. No? Psi plus phi, mod psi plus phi the whole square. It's like saying mod psi. What is the meaning of that? Mod psi the whole square. Okay. Correct? Tell me if not. Or confused? I repeat. I hope you remember. What is the meaning of psi? Psi star psi? It means psi star. It also means what? Mod psi square. You know? Okay. So psi is mod psi square. So psi plus psi is mod psi plus phi square. Okay. And you have under root. So this is basically psi plus phi. So in vector world, this is magnitude of a vector plus b vector. That's what I think. Less than or equal to. Okay. Similarly, this is, what is this guy? Remove this. So under root of psi. So this is equivalent to under root of mod psi square. So this is just mod psi. Okay. So this is just magnitude of a vector. plus similarly this is just magnitude of the vector. Okay, let's take two examples and check this beautifully. Okay, we will take one linear dependent example and one linearly independent example. So again I'm taking 2 I cap plus 4 j cap. Let's first take linear dependence, 4 I cap plus 8 j cap. Now please check. I think equality should exist. Check please. This is fun. Tell me if you have any questions. I've just doubled them up. I've written the vector as 2 A vector. I've used a linear dependence here. See if equality exists. I hope it does. Outstanding realization in that case. I will also do it. Magnitude of A vector plus B vector. So that's 2 plus 4 is 6. 4 plus 8, 12. So LHS is 6 I cap plus 12 j cap. So that's under root of 36 plus 144. So that's under root of 140, 180, 190. No, 180. Okay. And next, less than or equal to magnitude of A vector. So what do you have? Magnitude of A vector, 2 I cap plus 4 j cap. So that's 4 plus 16. That's under root 20. And then I have magnitude of 4 I cap plus 8 j cap. So that's magnitude of 16 plus 64. That's under root of 80. So under root of 20 plus under root of 80. That's RHS. I can write this as under root of 20
Yes,
plus
yes,
4 under root of 20.
I
So
didn't
this
think
is 5 under root of 20. Is this 5 under root 20? No.
No sir.
क्या हुआ?
Different है.
Different आ रहा है या मैंने गलत लिखा है?
लॉजिक गलत
सर
लग
मेरा
रहा
तो सर मेरा तो सेम ही आ रहा है
Same आ रहा है?
हाँ सेम ही आ रहा है
Okay, 2 I cap plus 4 j cap. When you add A vector plus B vector, 2 plus 4 is 6. 4 plus 8 is 12.
क्या चलिए
So this is under root of 36 plus under root of 44. 144. So that's under root 180. है ना? And then here, what do you have? 2 I cap plus 4 j cap.
है सेम आ रहा है सर
आया? Under
Yes,
20. Under root 80. Under root 20 plus 80 आया ना?
220
सर
अच्छा ये 2 root 20 4 root 20 ठीक है हाँ
आप लोग आसिम योर आसमान
3 root 20 अरे हाँ so this is 9 into 20 3 root 20 अरे तालियां great outstanding. Okay, so linear dependence, then things work. Otherwise less than होगा, then you can check. You can make this 7, make this 9 and check later. We'll stop here people. We'll meet tomorrow. Thanks so much.
सच में पता ही नहीं चला टाइम कब निकल गया
Happy to know.
थैंक यू
सर
सर
नेक्स्ट पेज
हाँ जी
सर आई एम आस्किंग अ बेकार क्वेश्चन
पूछा
sir just I don't know the question is good or not
okay
just
fine.
we are writing that the product of bra vector and kit vector we can write something in any circumstances that is first kit then bra that is can we write
in reverse, like in reverse order.
no that in not that in condition just asking can we write the kit or then bra
Wait. For example, if I have sci-fi, what are you asking me then?
bra kit the order can we write kit and bra that's right that,
Acha, okay, now this thing.
yes can
No,
does
this is
it
fine.
exist or not?
This exists, but this does not exist. This like what do you write? This exists actually. This I think so exists, but the other way around. Like when you write it this way, what do you say? Psi into psi. This does not exist, and phi like phi and bra could not be multiplied, and ket and ken could not be multiplied. But hang on, I have noted this purposely. I was supposed to tell you this later today. Just a second now. I will tell you. I've noted this. So, absolutely, this exists. I've written it. But just said a bra cannot be multiplied with a bra, a ket cannot be multiplied with a ket. So in quantum mechanics, this cannot exist. Psi and phi. This cannot exist, and this also you cannot calculate this. Yeah.
ये क्या bra है
And ket. Ket can.
और bra conjugate kit है क्या conjugate तो वही होता है ना
Basically, bra and ket should be back to back always. You cannot have a ket with ket. You cannot have a bra with bra. These two don't exist first.
okay thank you
No problem. So I'll end the session.
Okay, thank you sir.
No problem.
Thank you sir.
No problem.
Thank you, sir.
No problem.
Thank you sir.
No problem.